Hello everyone. Welcome to the solution of LeetCode problem 1971 named Find If Path Exists in Graph. In this problem, we are given a undirected graph and two nodes, which is source and destination. Now we have to determine if there is a path exists between the source and the destination of this graph. So here, in the first example, you can see that the graph has three nodes, which is 0, 1, and 2. And the source is 0 and the destination is 2. So we can move to the node equal to 2 from the node value 0 by moving 0 to 1 and 1 to 2. So it is possible that we reach the destination from the source. But in the second example, the source is 0 and the destination is 5. So source is here and the destination is here. So there are no path between source and destination. So it is not possible to us to reach the destination from the source. So we have to return false here. I hope you understood the problem statement. Now let's move on to the algorithm. In this problem, to understand the algorithm, we have taken the second example. Now here, the number of nodes that can be possible is 6. So there can be 0, 1, 2, 3, 4, and 5. So in total, there are 6 nodes. Now, let's make the connection between them or establish the edges. The first edge between 0 and 1. The second edge between 0 and 2. The third edge between 3 and 5. The fourth edge between 5 and 4. And the fifth edge is in between 4 and 3. Now, we have to determine whether I can reach from nodes 0 to 5 by using the traversal. So here, we can solve this problem by using the DFS or BFS algorithm, but here we will use the DFS algorithm. So before jumping into the solution, let's make the edge into the adjacency list. So in the first, there is an edge between 0 and 1. So we will insert the value of 0 will be 1 and the value of 1 will be 0. Then there will be a edge between 0 and 2. So 2 will be inserted here. And this is, then there is 3 and 5. So we will insert 5 in the key of 3 and we will insert 3 in the key of 5. Then there is 4 and 5. We will insert the 5 in the key of 4 and we will insert the 4 in the key of 5. And the last is 4 and 3. So we will insert the 4 into the 3 and we will insert 3 into the key of 4. So this is the adjacency list representation of this graph, and we are given a source node and a destination node. Now we will start the DFS from the source node and traverse through its adjacency list, and we will determine whether we can reach to the destination node or not. So here initially let's take a vector which has the size of 6. Initially all of them are initialized with false. That means none of the node is visited yet. So now our starting position is 0 and make the first visited. And from 0, we can go either 1. So we are at this position 1. So make the 1 visited. Now from 1, we can go to 0. But 0 is already visited here. So from 0, we can go to 2. So make the 2 visited. Now from 2, we can go to 0, but 0 is already visited here. So our DFS has stopped here. That means the other node, which is equal to 3, 4, and 5, is still become unvisited. That means the visited array is represented by the false. So we can see that after starting the DFS function from the source, we cannot reach the destination because the destination cell's flag is equal to false. In this case, we have to return false. Otherwise, if by using the DFS, we can reach the destination, we have to simply return true. And the overall time complexity of this algorithm is big O of n, where n is the number of nodes presented in the graph. I hope you understood the algorithm. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function named validPath, which has integer n and the list of edges, source and destination as the parameter. Now we are taking a visited array, and here we are initializing the false variable or the false value to each of the node. Currently, all of them are unvisited. And we are taking an adjacency list, and we are making the adjacency list here. Now we are calling the DFS into the source node. And inside this DFS function, we have to make the node visited. That means we have to assign true value to the visited array of this node index. After that, we have to iterate through each of the children of the adjacency list of this node. And if any of the children is unvisited, that means we have to again recursively call the DFS function with these children. Finally, we have to return the destination index of the visited. And if we have reached the destination from the source, it will return true, otherwise it will return false. I hope you understood the code. Thank you everyone for watching the video. We will get back soon with another LeetCode solution.